Hi, good afternoon, 8th grade. How's everybody doing out there? Hope everyone's okay. We are going to start today with another warm-up, simplifying expressions. You got 4 to simplify. Hey, Harmony, how you doing? All right, the goal for today, we're going to compare digital media and computer hardware using scientific notation. It's going to be a little mini project. Hey, Thais. Good. I'm glad you're doing good. I'm actually okay. Thank you for asking. And ladies, thank you for being consistent. I see you've been joining each day, and that means a lot to me. All right. You guys make the video a bit more than just math. You know, you make it more interactive. You make it like a class. So thank you. All right. We're going to do the warm-up first. We're going to review the homework, which was number 1 of the lesson 15 practice problems. I'm going to take any questions that you might have because I'm hearing through comments and emails that you guys have some questions out there. So I'll open up the floor and take some questions. And then from there, I'll introduce our mini project. It's really, really mini. So don't get worried about that. And I'm going to go over an example for you so that you know what you should be doing. All right. All right. So let's get to the warm up. Let's simplify each expression. The very first one says, if you have 10x squared divided by 2x, what could you simplify that to? All right. And I'll do that on the big board in just a minute. Okay. No problem. Number 2 says 2x times 3x to the negative 1. Number 3 says 1 times 10 squared plus 2 times 10 squared. Number 4 says 4 times 10 to the third minus 1 times 10 to the third. So hopefully you see what we're doing here with the simplifying expressions. We are basically practicing everything that we've already learned. And it'll help you with any questions that you might have. It'll help you with the other assignment that we're going to look at. Okay? All right. Let's get to it. So, very first one. We've got 10x squared divided by 2x. All right, I want to see what you guys think. Hey, Dagny, thank you for joining us. This is our very first problem for our warm-up. Let me know what you get or what ideas you have, please. Anybody else here? Who else is here besides Harmony, Thais, and Dagny? I need you to say present or type your name so I know who's here. They're asking us to keep track of that every day. All right, so hopefully, hey Sanaya, how you doing? Hopefully you guys are going to tell me, well, 10 divided by 2 is 5, Miss Leggett, so we can at least simplify the coefficients, right? Hey, Jacqueline, how are you? Boy, the ladies are really representing here, huh? Good job, good job. Okay. So for number 1 of the warm-up, 10 divided by 2 is 5. And what happens with the x squared and the x? Well, if I have 2 on top, I have 1 on bottom. X divided by x is 1. So what are you left with? You're only left with 1x. So the answer to number 1, simplified, is simply 5x. Now, you could have also told me the exponent rule, that when you divide, when bases are the same, you can simply subtract the exponents. The exponent here right now is 1. 2 minus 1 is 1. We just usually don't write the 1 because it's understood. Hey, Camila. Nice job, guys. Keep it up. Keep it up. Do you guys have any questions on number 1? Okay, I'm going to do number 2 now. We have 2x times 3x to the negative 1. Same idea here. What's 2 times 3? It's 6. And then if I have same base, what do I do with those exponents when they're connected by multiplication? Hopefully you guys remember we add. So what's 1 plus a negative 1? That's a 0. Anything to the 0 power, though, is 1. So I'm actually looking at 6 times 1 here. So surprise, surprise, no more variable. All we have is 6. Good job. Yes. And that's number 2. Okay, number 3. We've got 1 times 10 squared plus 2 times 10 squared. Okay, now this looks much different, right? But we did practice this yesterday. So luckily, my bases are the same. This is almost as if I was looking at 1x plus 2x. It's almost just like that, because this base is exactly the same. Those bases are the same. Combining like terms, we would just say 1 plus 2 equals 3x, right? Well, then we can actually do the same thing here. What's 1 plus 2? It's simply 3. And if you weren't sure if you're allowed to do that, you can actually expand them, because these numbers, they're actually not that bad. 10 squared is 100, right? Well, what's 1 times 100? Is just 100. So if this right here, and I'll use a different color. If this one right here represents 100, what does this represent? This represents 200. And if you add them, you get 300, right? Well, what's this right here? This is actually 3 times 100, and 3 times 100 is 300. You get the same thing. You get the same exact thing, which means that what we did is correct, okay? Now, you don't have to tell me 300. I said simplify the expression. Simplify the expression, just put that. Okay, how about that one? Any questions on that one? Okay, if there's no questions, then I'm going to go ahead and go to the next one. The last one in the warm-up was number 4. Go over it again. Okay. Okay, but I want you to, I'll go over it, but I want you to keep something in mind. This video gets posted on the classroom, so it's something that you can look back at. If there was something that you didn't understand, or if there was something that you missed, or you missed the stream completely, this is a very useful way for us to stay connected, because you get to participate in the stream, but then you also get to look back at it if you need some extra help or you need to see it again. Because, you know, like, let's face it, sometimes we space out, right? Or sometimes we have to go to the bathroom, or there's some kind of interruption and they're like, hey, over here, and then your attention is diverted. You get to go back and look at the video. So if you needed to see number 3 again, then later on, you just look back at the video. You don't have to look at the whole video again. Just go to where we're going over number 3, and then boom, you get to see it again. Okay? What's the matter? Okay, I'll go over it again very briefly, but like I said, anything that I do in the stream, you're gonna get to see it again. Okay, no problem. So 1 times 10 squared plus 2 times 10 squared. These bases are exactly the same, which means I can just simply add the coefficients. 1 plus 2 is 3, so it's 3 times 10 squared, and you actually don't have to do anything further. This is the simplified version. What I was doing is I was explaining that if you weren't sure what to do, you could expand it. This right here is actually 1 times 100 plus 2 times 100. Well, what's 1 times 100? It's 100. What's 2 times 100? It's 200. 300. What's 3 times 100? Is 300. So you could check yourself to make sure that you did something correct, all right, and that you didn't miss anything. Okay. Guys, remember that if you've just joined us, please type present or your name so that I can write you down. Okay, last one. Okay, lucky for us, the bases are the same again, right? It's much less of a headache or work. 4 minus 1 is 3, and I keep my base the same, so boom, that's it. That's all you have to do. You want to double check? What's 4 times 1,000? What's 1 times 1,000? Add them up. Oh, subtract, right? $3,000. What's 3 times 1,000? 3,000. We got the same answer. You guys have any questions on the warm-up whatsoever? Okay, if you don't have any questions on the warm-up, then the next on the agenda is to go over our homework. Homework was number 1 from lesson 15 practice problems, and it looks like this. If your answers don't match up, it could be because you didn't do it in scientific notation. Yes, Dagny. The agenda, right after we go over the homework, the agenda has us scheduled for any questions that you guys have. And it seems like you have questions about yesterday's classwork or some kind of classwork assignment. So that's going to be the time to ask me, okay? So prepare your question and type it in the chat. Right, if your answers don't look like this, it could be because you didn't put it in scientific notation. Please make sure that if you put your answer in scientific notation, you get the same thing that's here. If you have any questions, please let me know. Good afternoon, Zasha. Thank you for joining us. Man, the ladies are really representing. You go, girls. You go. I'll show that one more time. I didn't get D right. Why are you laughing at that? What's so funny about that? You want to go over it? Okay, cool. Okay, I'm going to show this one more time, ladies. And if the gentlemen are looking later, gentlemen, haha, I'm going to go over letter D. Remember that your answer has to be put into scientific notation. That could be why you got it wrong. I don't know. We're about to go over it. 6.6 times 10 to the negative 5. Take away 6.1 times 10 to the negative 5. Now, once again, these bases are the same. So they made our life somewhat easier than it could have been, right? So let's do, what is 6.6? Take away 6.1. What is that? Think about money. Think about $6.60. And if you took away $6.10, like if you spent money, you'd only be left with 50 cents, right? So if I'm left with 50 cents, then it's 50 cents times 10 to the negative 5th power. Now, this is not scientific notation, and hopefully you recognize that. Hopefully you recognize that this is not a number between 1 and 10. It's less than 1, and that's not okay if it's going to be in scientific notation. So if I need my decimal point over here, what does my exponent become instead? And if you're not sure, just expand it out. Where do you, positive 5? 5 times 10 to the negative 6th power. And who is FYM? If you're in here, you need to tell me who you are so I could take attendance. Kevin, hey, how are you? Positive 5 times 10 to the negative 6th power. Kevin, thank you for coming into the stream. Represent the guys a little bit because the girls were taking over. Are you guys okay with this? I wanted to show you expanding it. If you weren't sure, what is 0.5 times 10 to the negative 5? It just means to move the decimal over, right? I have to start here, and it says to move it to the left 5 times. 1, 2, 3, 4, 5. So there's my decimal point now. Let's test this one out and make sure that we get the same exact number. Now, the decimal point is actually right here, and let's move it back 6. So 1, 2, 3, 4, 5, 6. And we actually do get the same. So if you were not sure, you could have checked. Voila. Where did you get -6 from? So, Jacqueline, this was our answer, but they want the answers in scientific notation. I circled it in your in the directions. So even though we got the answer and the answer is correct, this is what happens when you subtract those two. They wanted the answer in scientific notation. If you're going to put it in scientific notation, remember that this coefficient, this numerical factor, it has to be between 1 and 10. 50 cents is not between 1 and 10. So if I move my decimal this way, it's actually creating an extra 1 to have to go to the left. Because the negative is telling me to move to the left, right? It's telling me move that decimal to the left. You're actually, this is the same thing. I don't know if this will help or not, but this is the same thing as 0.5 times 1 over 10 to the 5th power. You're actually multiplying it by a fraction, so you're technically dividing, and that's why the decimal point is moving to the left. I hope that answered your question. This current where we are is going to be on Classroom as soon as we're done. So approximately 1:30, I'll be uploading this video because right now it's a live stream. Yes. Any assignments are still in the classwork tab like usual. I haven't changed that. Okay. I did for our mini project, I did have to put a document up on Classroom so that you guys could see the information. I'm not there to hand you the cards. So I put that on Google Classroom today. That's actually different. I don't normally have to post something for you guys. Before I take more questions on different things, I want to make sure that this was okay and that nobody has any questions on any other problem. Any other questions on last night's homework? Okay, cool. How about the homework from the night before? I had asked during one of the streams, but I want to ask again, just in case someone didn't have the work done, and now maybe you have it done. This is lesson 14, practice problem number 1. And it was actually due yesterday. So did anybody have questions on this one? Okay, cool. So then we're gonna move on to questions that you have on anything else. So Dagny, I would like to know which classwork assignment you have a question on. Was it the classwork that we did in the stream yesterday, or is it something on Google Classroom that you have assigned to you that you need to do? Zasha, you can do it because I attached the practice problems on Google Classroom in the classwork tab. Dun-dun-dun. Hi, Esklin. The one that was due yesterday. Okay, can you give me a title, please? Lesson 14. If I did not post that one, I can do that for you. Do you want me to do that? The most recent one that I assigned. Okay, Zasha, I will post lesson 14 practice problems. I'll add the file to the post because the post was there since I assumed everybody had their workbooks. What I assigned for lesson 15. Dagny, you got to give me a title. It says Unit 7, Lesson 15. So you want me to help you with that classwork? Elena wants to add 2.3 times 10 to the 5th plus 3.6 times 10 to the 6th. Is that the one that you were referencing, Dagny? Okay, cool. So did the warm-up and going over the homework, did that help you at all? Because it's a lot like that. Sort of. Okay. All right. I'll put it up. Because I want to make sure that you guys understand and you're doing well. So it says 2.3 times 10 to the 5th plus 3.6 times 10 to the 6th. Explain what her mistake was and what the correct solution is. Okay, so what I'm going to do is I'm not going to look at what she wrote. Okay? The reason why this one is different is because these bases, they're not the same right now. So let's make them the same. Let's make them either both the 5th or both the 6th power. Pick one for me. Pick one. Okay, pick one. Do you want to make this one the 5th power or do you want to make this one the 6th power? Okay, so we're going to change this one to the 5th power. So we're going to leave this one the same. Now, if you want to make this one the fifth power, that means that you're going to move less spaces to the right. So that means you have to take one away from the right. So I'm going to move it. And now since I already moved one, I could take it away from here because I already made a move to the right. Okay, so I am reviewing right now on Google Classroom. I had posted an assignment called Unit 7, Lesson 15. It was the exit ticket, basically. And Dagny has a question, so we're going to go over it. Now that these look the same, and if you're not sure, you can always check, right? You could check in your calculator, you could check on the side. 3.6 times 10 to the 6th power, is it the same as this one? And you should get the same result. Now we can actually add them. So what's 36 plus 2.3? So again, think about money. If you had $36 and you had to add it to $2.30, wouldn't that just be $38.30? Now, technically, this is not in scientific notation right now. In order to have it in scientific notation, this number has to be between 1 and 10. That means it has to be 3.83. But I moved it back, which means if you're moving it back, you technically have to move it more to the right. So if this is what the actual answer is, what did this person get that was doing the work? Elena actually got 5.9 times 10 to the 6th. So what did she do wrong? Well, she added them when she wasn't supposed to. There's a 10 to the 5th and a 10 to the 6th. She should not have added them the way they were. I hope that helps. Do you guys have any other questions? On either that assignment, the Unit 7, Lesson 15 that's on Google Classroom, on the homework, Moby Max, anything? Let's see what we got here. 30. Okay. Okay. So what was her mistake? Her mistake was adding them in the beginning. So see, she got 5.9 because she did this. What's $2.30 plus $3.60? It's 5.9. She was not supposed to add them. She couldn't add them because these are different. These are different bases. It's like X and Y, A and B, but they're not the same. You're not supposed to add the exponents. Her mistake was adding before making the bases the same. She has to make the bases the same before adding or subtracting. Okay, cool. Do you guys have any other questions on any of the other work? I am a little concerned because I haven't seen enough people doing the Moby to make up for certain like quiz or test grades, but I could post a reminder on Google Classroom for that. Many of you have not done systems, and I need you guys to do the systems on Moby. Okay, it doesn't look like you guys have any other questions, which means we're ready for our mini project. I need you guys to turn to 16.1, lesson 16, activity 1, please. Yes, Thais, I believe you did. Mini project, mini. Don't start panicking, okay? Okay. In your book, it should be page 121. I need you to go to this enticing activity right here. Okay. Hopefully that's not too blurry. But you guys get the idea. It's in your book, or you could go to the website for your book and just make sure you go to Unit 7, Lesson 16, Activity 1, page 121. 121? Yeah, 121. All right, now, I have to make a couple of mentions here. Number one, on Google Classroom, I posted a chart of information that you need in order to complete this mini project, okay? Or activity, we could say. So first, you need to view that at the same time, okay? And the document is, it says today's stream. And when you open it up, it's gonna have a bunch of boxes of information. 1966 Apollo guidance computer, 2007 smartphone, okay? Open that up so that you have the information. And I need to also point this out. On page 122, there is actually, I don't want to rip this, but I don't want you to, okay, maybe I could do it like this. On page 122, there's this little note at the bottom of the activity. It's conversion rates, basically. And we need this information for the activity also. So I'm going to make some sense out of this reference before we begin. I'll keep it up here as a reference. It says that kilo stands for 1,000. And we're going to need that information because we're going to be converting things before we compare them. So kilo equals 1,000. Mega stands for 1,000,000. Giga is 1,000,000,000. And tera, you might need, depending on what you pick, but the one that I'm doing today, I don't need tera. So I'll just put down the giga. Because then I still have room to show you an example. Okay, you guys with me so far? So far, you're supposed to have the document on Google Classroom. You're supposed to have the reference information on page 122, and you're supposed to be looking at the activity on page 121, 16.1. That's what we're doing right now. Okay, cool. Okay, now, this is actually kind of interesting. All right, it says here that in 1966, the Apollo guidance computer was developed to make the calculations that would put humans on the moon. And I want you to keep this in mind. Humans on the moon. I don't want you to forget this while we're doing the activity. I want you to keep this in mind. This is your reference point. 1966. They created a computer that would take humans to the moon. You're probably saying, Miss Leggett, this is not science or history class, right? Well, math permeates all of life anyway, so in my opinion, it makes the math more interesting anyway. Okay, now where it says your teacher will give you the advertisements, that's the document that I shared with you with all the boxes of information. Number 1, which one can store more information and how many times more? This is the mini project that I have. You see how it says for number 1, you have to see which one is carrying more information? You have to pick one of the devices on the list that I shared with you. So I want you to look at the list real quick of the boxes. Now, you don't pick the Apollo Guidance computer because that's the one that you're going to be comparing it to. And unfortunately, Miss Leggett took the 2016 smartphone. That's the example I'm going to do with you. So don't hate me. 2016 smartphone. That's the example that I'm going to do. So that means that you guys have to either pick the 2007 smartphone, the 2016 desktop computer, or one of the older desktop computers, 1977, 2001, 2007. You get to pick any one of those for your mini project. Okay, cool. So make sure you picked one. And if I was in this class and I picked this one, I'm going to show you what I'm supposed to do for the work. Now, there seems to be a glare still. See if that helps a little bit. That might help a little bit. Someone tell Kevin what we're doing because I really am not going to repeat all that. He can look at the stream. Okay, now if I want to compare them, when you take a look at the smartphone, the information that is under the 2016 smartphone, it says that the storage is 32 gigabytes. But up here, I know that a giga is supposed to be the billion. So that's actually, for storage, it's not 32 gigabytes. I would write that down as 32 billion. Now, the other one that's in the box is processing speed. So I'm going to abbreviate that as speed. And for the speed of the 2016 smartphone, there happens to be 4 processors. 4 processors that are each doing 2.2 gigahertz. So first I would do 4 times 2.2, and I would get 8.8. And it's times 10 to the 9th. So you can rewrite that as 3.2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can rewrite that as 3.2. So if you were taking some notes down as to steps to complete this activity or mini project, your first step is to pick your device. Pick it, but don't pick the Apollo Guidance and don't pick the 2016 smartphone. So pick your device and then take the information on the card, storage, speed, and the last one is memory, and change the numbers into scientific notation. So for the 2016 smartphone, I see that it says that there's 3 gigabytes of memory. So for me, I would put down, since a giga is a billion, I would put down that it's actually 3 times 10 to the 9th power. And if that's not legible, there. Hopefully it is now. Are you guys with me so far? It looks like you guys might be with me, I hope. Okay. Now, okay, so remember, I said step 1. Step 1, pick your device. Step 2, put everything in scientific notation. All right, what's step 3? Step 3. Okay, I'm supposed to decide which one is actually able to contain more storage. This one or the Apollo computer from the very beginning. Obviously this one, right? Because it's 10 to the 10th power. What was the original information on the Apollo? It was only 75 kilobytes, and kilo is 1,000. It was only 75,000. This is way more than that, right? So obviously, the smartphone today holds more storage than the Apollo guidance computer in 1966, which is actually incredible. And that's why I circled this right here. Okay, that's why I circled that. It's putting humans on the moon. And our smartphones have more storage capacity, higher speeds, and are able to hold more memory. I mean, like, it's just incredible, right? Does that mean that your phone could actually send someone to the moon? No, that's a question. Okay. Okay, so step 3, decide which one for all 3 can hold more, go faster, and have more memory, right? So decide which one holds more memory, is faster, and has more storage. Okay, step 4 for your activity. Now you actually have to decide how much faster, how much more storage, how much more memory is this capable of doing. Now, I'm going to go back to a question that I asked you a while ago. It might have been yesterday or the day before that. If I want to know how many times 4 is 8, what would you tell me? You would tell me, oh, it's times 2. Well, how can you figure that out? For numbers that are not so easy, give me something that I can do all the time and I can depend on it. I think you guys told me just 8 divided by 4 will give me 2, right? And I could depend on that. So that tells me that 8 is 2 more times 4. You're going to do the same thing with these, and that's step 4. So I'll put that note here. 8 divided by 4 equals 2. So what do you have to do? You have to divide the ones that are larger. So if this one is the one that's larger, and I want to do that in a different color. That's right, you got it. So 3.2 times 10 to the 10th power, and I'm going to divide by the Apollo. And the Apollo computer was, for storage, 7.5 times 10 to the 4th power, because it said that it was 70, I think it said 75 kilobytes. Yes, it says 75 kilobytes. So 75 kilobytes is the same thing as 7.5 times 10 to the 4th power. Okay, well, what do we get when we divide those? What's 3.2 divided by 7.5? You would get 0.426, and the 6 is repeating. And what's 10 minus 4? It's just 6. Make this scientific notation. 4.2 times, actually, you can make that 4.3. 4.3 times 10 to the, and I have to go one less, right? So 5, 10 to the 5th. So again, if I was a student and I picked my device and I wanted to show my 3 answers, every single one should have 3 answers. You're going to have an answer for how much more storage can the device hold, how much faster it is, and how much more memory it has. So for me, I have my first answer. My first answer is that a 2016 smartphone has 4.3 times 10 to the 5th power more storage than the Apollo guidance computer. Okay, so that's number 1. Number 2 is speed. My speed, 8.8 times 10 to the 9th, divided by, what was the speed of the Apollo guidance computer? The speed of the Apollo guidance computer was 2 times 10 to the 6th. So you guys are actually going to be able to use these numbers in the denominator for your activity, whatever device that you pick. All right, plug it in, Kevin, plug it in. You can use this number, and this one is for storage. You can use this number, and this number is for speed. All right, what's 8.8 divided by 2? This one right here ended up being 4.4 times 10 to the 3, because 9 minus 6 is 3. Let me make that clear, because I don't know if this is clear right here. So how much faster? 4.4 times 10 to the 3rd faster. This would have been my second answer if I was a student in this class. Okay, hey Jorge. Try to be on time next time, if you can. Because we're about to be done, buddy. If you have any questions, let me know at the end, okay? Okay, I have one more answer. Okay, so I should have 3 answers. 1, 2, and now I'm going to work on my 3rd. So I'm going to erase my reference. I put that up there for you guys so that you knew where I was getting my numbers from. But my 3rd answer is going to be memory. So I could even label it 1, 2, 3. For the memory, on my 2016 smartphone, I got 3 times 10 to the 9th power. I got all this information off the document I shared with you on Google Classroom. The Apollo guidance computer, if you take a look, as far as its memory, it said 4 kilobytes. 4 kilobytes is 4 times 10 cubed. Well, what's 3 divided by 4? And let me highlight this because this is something else you could use for your activity. All the Apollo information is in the denominator, and you can use that for your assignment. 5 times 10 to the 5th. Okay, so I'll keep that up there for a bit because I'm sure people have to copy things down. The whole point of this was we wanted to decide if over the course of time, were devices able to store more, go faster, and hold more memory? Obviously, I didn't do the one from 1977, but you guys can. You guys can pick any of the devices except Apollo Guidance because that's the one you're comparing it to, and you don't pick the 2016 smartphone because that's the one that I demonstrated. You got 1, 2, 3, 4, 5, 6 other, wait, 1, 2, 3, 4, 5. 5 other devices that you could pick from. I need you guys to pick one device. Pick one device. Get the scientific notation, right? Get the device, pick the device, create the scientific notation for its data, storage, speed, and memory. Decide which one held more memory, which one went faster, and which one had more storage, the Apollo Guidance or your device that you chose. Divide them. Divide the larger by the smaller. So I'll update this one so that it's clear. You want to divide the larger by the smaller so that you know how much more times bigger one is than the other. When you're done, make sure that your answers are clear. You should have 3 different answers, and all 3 of them should be in scientific notation. Now, it's time for us to stop, but I'll take any last-minute questions on anything. Do you guys have any questions out there? What's your good news? That's cool. And believe it or not, it will help a lot. Do you guys have any other last-minute questions? If you think of a question, feel free to comment the question. And if it's too much for me to explain in a comment, I will address it in the next stream. Okay, then enjoy the rest of your afternoon. Stay on top of your work a little bit each day in every subject, and you'll be just fine, okay? Stay safe and healthy, and I'll see you tomorrow at the same time.